Hello friends, so welcome to our channel. So in the previous session we have seen methods of a thread class, and we have seen a thread life cycle and how to create a single thread, and we have also seen the creation of a multiple threads while explaining the join method. Right, now we will see the thread synchronization concept. Right, thread synchronization. So if you are working with multiple threads, then we can't predict which thread is going to be executed first and then which the schedule of this thread execution. So we can't predict. So that's why if you use this thread synchronization concept, then the thread execution will be one at a time, one by one. So simply we can say this if you apply this synchronization concept on the thread instructions, automatically whatever the thread is executing that instructions or executing the method, that thread will be in a lock procedure so that no other thread will interrupt this thread. So all the remaining threads will wait until this thread is to be completed. So see, let us see, 3 threads are there. So thread execution starts by using the start method. So t1.start, t2.start, t3.start. So if you observe, so t1 may initiate it first, t3 next, t2 1, or T2 may initiate it first, next T1, T3, or T3 initiated first, T2, T1, and so on. So we can't predict the order, right? Which one executes first. So if you apply this synchronization, whenever this T1 executes this synchronization block, automatically T1 will be in the lock procedure, right? Then whatever the threads are there, all will be in waiting state. So it will wait until this, so this is the synchronization. Until this completes its execution, all the remaining threads will wait in the waiting state. So after completion of this one, it will be unlocked. So automatically from these 2 threads, one thread will occupy this lock position. So if T2 occupies here, T3 will be in waiting state, so that it will wait until T2 completes its execution. Right? So this we have achieved by using join method. Right? So this we have achieved by using join method. Join method is also similar. If you apply join, so whatever the thread is present running, that will be executing and no other thread will interrupt the present running thread. So that we have seen in the previous session. But here the drawback is, if we want to synchronize some 100 of lines in the code, then we have to apply this join for 100 threads. So in order to avoid this, we are moving with the synchronization concept. So our system may have thousands of threads, right? So if I want to synchronize only few of them, right, then we will go with the synchronization concept. So this synchronization means locking the thread which is in the current position, current running, and all the remaining threads will wait until the current running thread completes its execution. So the same thing. So this can be achieved in 3 ways. This thread synchronization can be achieved in 3 ways. First one, by using synchronized keyword. Synchronized keyword. And we have to apply this keyword as a prefix to the statements which we want to be executed as a thread. Right? So generally we are writing these instructions of these statements in the run function. Right? So we are writing the statements which to be executed as a thread in run function. So we have seen two methods in the previous session, start and run. So the thread execution always starts with the start function, and whenever you call the start function, implicitly it will call the run function, so that we have to write the statements here. So these are the thread instructions, or these are the statements which are to be executed as a thread. So here the concept is we have to apply the synchronized keyword as a prefix to the statements which to be executed as a thread. So here we are writing the synchronized, so this can be done for a method. Right? Here, just correction. Prefix to method in which statements return to be executed as a thread. Right? Small correction. Right? So as per the explanation, we have to apply this synchronized keyword here. So we are writing this statement. So this we calling as a thread instructions, right? So whatever the statements we are want to execute under the thread. So according to this explanation, we have to use synchronized keyword as a suffix to this run method. But this is wrong, because we said that all the classes are the base derived class for a thread class. So this we have explained in the previous section, right? So whatever the class we are writing, that will be an derived class for the thread class. So that's why here writing some T extends thread. Right? So all the classes are the derived class for the thread class. Now if you want, so start and run are here. Those are the methods available here. So in order to execute this one, we have to create an object for T. So T1, and we have to apply this start method. Right? T1 dot run. Automatically run will be executed. So that means we are overriding this run function from the thread class. So method overriding. Right? So these are all the methods available in thread class. We are accessing these methods and we are writing our own instructions in the run method. That means run method is a overridden method. So what is the rule for overridden method? The name, the parameters, the scope, everything should be same in both the derived class and the base class. Only the instructions to be modified. That we have seen in method overriding. But if you apply this synchronized keyword as a prefix to this run method, so this is not a overriding method. So it will not execute the statements because this is not overridden. Right? So that's why we will go with another approach. Right? So we will write this run So we will write this run in one more class. See, some class T extends thread. So we will write all the instructions which we are writing on the run in separate method. Now we are writing all the instructions here. So we can write some other class here, right? And we will call this method here itself. Hope you understood this one. We are not writing the synchronized keyword here, but we can apply the synchronized keyword here itself. So we will call this method here. So whenever t1.start, automatically run will be applied, and immediately after executing this run, display method is called, so that this function will be executed. Right? So how this happens, we will see while implementing this thread synchronization concept, so that your doubts will be clarified. Right. So now this is one way how we can achieve the synchronization. Now second thing, using synchronized block. See, here we are applying synchronized keyword for a method in which statements return to be executed as a thread. But if we want to restrict the synchronization for a few lines of a particular method, so in a method we can have a number of lines. So if we want to restrict a few lines of a method as a synchronization, then we will go with the synchronized block. So this is simple. So how to represent a block? So a block can be represented by using a curly braces. Right? So here synchronized block is represented by using synchronized keyword. Synchronized. So we have to pass this as an argument, that means a current running thread. This and this one. So here we can write the statements which we want to execute in a synchronized mode. So inside the method we can apply the synchronized block. So this should be applied inside the method. Few lines if we want to restrict this synchronization for few lines in a method, then we will go with synchronized block. Synchronized block. Right? Hope you understood. The first procedure is using the synchronized keyword for method. Second one, applying the synchronized block for a few lines of a method inside the method. Right? Now the third approach is synchronized static block. Synchronized static block. We know that. So this is also applied for a method, right? So this is if we apply the static keyword before a method, then we can say that it is a static method, and all the static methods can be called by using the class name, and we need not create an object for calling these static methods. So a class may consist of a methods. If it is a normal method, we have to create an object for that class, and through that object only we have to call the method. If it is a static method, we need not create an object for a class. Directly by using the class name we can access the method. So similarly, this is also applied for method, complete method. So we have to use a keywords synchronized static followed by return type and method name, right? So a block, this is also a block, right? So this is a third way how this synchronization can be achieved. So hope you understood this one. Synchronization can be achieved by using three approaches. First one is using the synchronized keyword. Second one is synchronized block. The third one is synchronized static block. Right? So here one thing we have to remember, that is we are not writing the statements in the run, because if you write the statements in the run function, so applying these synchronized keywords to the run function is not possible, because run is a overridden method from the thread class. So that's why we are writing the instructions in another method in another class, and we are calling that particular method in the run method, right? So for this we will use the code, a different code for implementing the multi-threading, and then we will see these three approaches. So first we have to learn how to create a multi-threading, and then we will go with the thread synchronization, right? So we will see all these three concepts. So first one, multi-threading for this synchronization concept. Next, thread synchronization using synchronized keyword. Next, thread synchronization using synchronized block. Third one, thread synchronization using synchronized static block. So we will see all these implementations in the system. I will show you the execution of the program. So how we have to write the program for implementing this synchronization concept, right? So let us see that.
Hello friends, so just now we have seen the usage of synchronization, thread synchronization. So before going to the programming, so let me recall that. So if you are using this multi-threading concept, multiple threads will run at a time. So user can't predict so which thread is going to be executed first and then next. So that's why we will go for the thread synchronization. So in the thread synchronization, we have seen three concepts. So three ways how the synchronization can be achieved. The first one is using the synchronized keyword, second synchronized block, third synchronized static block. So whatever it may be, if you keep the code which we want to run under the synchronization concept, automatically there will be a lock towards the thread, so that no other thread will execute until the thread which has been synchronized, it completes its execution, right? So whatever the thread is running, that will be in a lock procedure. So just we can say the synchronization is just like a locking procedure. So it will lock, and then after completion of that block, then the remaining threads will be get executed. Now let us see the normal multi-threading concept, and then we will move with the synchronization concept. Now let us create a multi-threading concept, right? See, just we will import the statement. Next, here in this concept we have seen the thread life cycle, that is start, run, right? Start and run methods. So every thread will start its execution with the start function, and that start function immediately or implicitly calls the run function. So whatever the procedure or whatever the statements we want to execute under the thread should be written in run, and all the programs are, all the classes we are writing, those classes are derived classes of a thread class, right? So that means we are overriding the run method that we have seen in the previous session. So we'll write here, see, class. First I will write the program, then I will explain one by one. Example. So here we will write the function which we want to display under the thread, run under the thread. Is equal to 0, I less than or equal to 5, I plus plus. Right here we will use a sleep method, right? We will use the sleep method. So a sleep method should be written in try and catch blocks. I'm writing here try. As sleep is a static method, we need not use the object, so thread dot sleep, and I am passing 1000 milliseconds as the parameters, so that much seconds it will be in suspended. Catch exception E. So empty block. Let us create an empty block. Hope you understood this one, right? We are writing one function, one class. In class we are writing one method. Sorry, yeah. Let us display here thread dot sleep. Then let us display the I value. Println g dot get name plus empty. Oh, sorry, yeah, plus I. So I am printing just I. So this is the instructions we want to execute under the thread. So if you call two threads will execute the same code. That means printing the values from 0 to 5. So if one thread is getting executed, we'll start the thread by using start method. Immediately that will be coming here, right? So it will explicitly calls the run method. So here we are writing the display method. So we have to write the run method. Under the run method we have to call the display method. So why this happens, I will explain you later. See, now let us write the thread concept. T extends thread class. So here we'll give a reference to the class example, and we will write the constructor, a parameterized constructor. In the parameter also we are writing one, right? So we have written. Now we will write run function, public void run. So this is a overridden function, right? Now we can write e dot display, right? So I will explain you everything, you don't worry. Now we will write the main function. Tsync, write the main function, static void main string arguments, then write object for example class, create a thread, t1 is equal to new t of ex. So I will explain you, right? So t2, I am creating this second object for the same thread class, new t of again ex, t3 is equal to new of t of ex, right? Now let us start everything. T1 dot start, t2 dot start, t3 dot start, right? Here see why we have written like this. So why we have written the instructions what to be executed under the thread in separate class. This is because here whatever the class we are creating, that is the derived class of a thread class, right? So we are overriding the run function, So here overriding the run function means the scope, the parameter, the function name, and everything should be same in both the base class and derived class. So here, as I have explained, to implement this synchronization concept, we have to use the synchronized keyword as a prefix to this public void run. That means whatever the code we want to run under the thread, in that method we have to apply this synchronized keyword. So here actually in the run function we are writing the instructions to be executed, so we have to place the synchronized keyword as a prefix to the run method. But if you place this synchronized keyword as a prefix in the run method, the overriding is not happen, because there is a difference between the function defined in derived class and the function defined in base class. So that's why we are writing a separate class and a separate method, and we are calling that method in the run method, right? So what is the use of all these things? So then directly we can call this example.display, but why are we creating all these things? See, let me explain. Let us test one by one. So always starts from our program, always starts from main function. So first main function will be executed, right? So in the main function, we are creating one object for the class where we are writing the thread concept, threading instructions, and we are we are creating three objects for a thread class, right? So creation of an object consists of a constructor with the help of constructor. There we have seen two types of constructors. One is default constructor and the parameterized constructor. Now here we will use this parameterized constructor because, see, this is the thread class, right? So this is the thread class. So in the thread class, we are creating an object for the above class, right? Example, because in this class itself we are writing the instructions, right? So here we are creating an object, and see, this is an instance variable, example E. Now if you write e.display here without writing this constructor, it doesn't execute because the scope of e doesn't valid inside the method, right? So for this purpose, we are creating an object for the example class, and we are passing that argument while creating the object of thread1. So automatically we have seen the constructor example in the previous sessions. So the first it executes the constructor, it will search for the constructor in the program, then only an object will be created. So here it will search for the parameterized constructor, so that's why we are writing t example of e. So that's why this object reference is assigned to e. Hope you understood here. This object reference, that means whatever the instructions we are writing under the execution of a thread, that object reference is passed as a parameter to the constructor. So that's why we are again calling this constructor parameterized constructor. Again we are creating an example of e, object of e. Then here we are assigning, right? Here we are assigning this reference, see, this reference to this example, this object, right? We are defining this reference to this object. Now directly we can call e.display so that display function will be executed. So that here thread g is equal to thread.current thread. So thread G will be having the current thread reference, current thread. So here which thread calls this display function? T1. So that's why T1 reference will be available in current thread. So here it will sleep for 1 second and again get g.getName. So g.getName. In the G we are having the current thread reference. Current thread is T1. So T1.getName will be executed plus I will be printed. So 0, 1, 2, 3, 4 and 5. And immediately the same procedure will be happens when creating the objects T2 and T3. Right? So that's why we are writing two different classes. In one class we are writing the instructions of a thread, and in the another class we are writing the run method, and in the run method we are calling the thread class. I mean the instructions of a thread which we are writing. That class we are calling in the run function. For this calling, an object should be compulsory needed, right? So in order to call an method of a class, we need an object for that class. First we have to create an object for that class, and through that object only we have to call the method. So that's why here we are taking a constructor and we are making a reference. So that's why we are using this function. Now let us see, let us execute and see this one. So T synchronization.java, tsync.java. Let us create in threads concept, right? So why we are writing this one? Because the thread instructions should be written in run function, and in order to execute the synchronization, thread synchronization, we are using a synchronized keyword as a suffix to the method where the thread instructions has been written. So we can't write this synchronized keyword as a prefix to the run function because run is a overridden function. So that's why we are creating two different classes. Now let us execute this one. So this is multi-threading without synchronization. Right. Okay. So here instead of writing full stop, right. Now let us see tsync.java. Right. Now let us execute. See, thread 2, thread 1, thread 0, thread 1, thread 0, thread 2, right? So now you can observe the disadvantage of multi-threading. So there is no specific manner how the thread is going to be executed. First thread 2 is initiated, next thread 1 initiated, next thread 0 initiated. And in the second iteration, thread 1 initiated first, next thread 0, next thread 2. In the third iteration, thread 1 initiated first, then thread 0, then thread 2. So there is no a proper manner how this thread is going to be executed. For this, we can apply the synchronization concept so that a thread in which we are applying the synchronization, that will be in a locked state. So until that particular block is going to be executed, then no other remaining threads will be executed, starts its execution, or it will interrupt. Now let us apply the synchronization. So just a simple, the first method we have to use synchronized keyword as a prefix to the method where we are writing the thread instructions. So here all the thread instructions has been written in void display. So here we have to use synchronized keyword. So everything in a small letter, synchronized void display. See, so we didn't change not even a single line. Only we are applying the synchronized keyword as a prefix to the method in which we are writing the thread instructions. Now let us execute, and now let us execute and see this one. See, so thread 1 is initiated first, so that the thread 1, I mean thread 0, first thread. So first thread is initiated first, and that will be in a lock state, so that no other thread will be starts its execution. So once thread 0 completed, next immediately thread 2 started its execution. So thread 2 will be in a lock state, so that thread 1 will not interrupt it. So after completion of thread 2, thread 1 executes. So here you can observe the procedure. So if one thread is being executed, no other thread will interrupt it, or no other thread will execute, right? So this is how we will achieve the synchronization. The second approach is synchronized block. So our system will be having a more number of instructions, so we can have in the method also we can have a multiple lines of code, and if you want to restrict some lines of code to be synchronized, then we will go with the second approach, right? So if I want to execute this one, I will write complete this one with a synchronized block, synchronized this. So we have to use this word, right? So this is the synchronized block. This is a synchronized block. So if a method consists of multiple lines of code, then if you want to restrict this locking procedure for only a few lines, then those few lines can be combined with a synchronized block. So we are not applying the synchronized keyword to hold the method, but we are applying the synchronization for some multiple of lines, some lines, a few lines. See, now we will execute this one. So here also, yes, thread 0, first thread 0 initiated. So thread 0 will be in locking state, no other thread will start its execution. Next, thread 2 is initiated, so thread 2 will be in a locking procedure, so no other thread will be starting execution until the thread 2 finish its execution after the thread 1. See, now if you write the same code just above, see, now let us observe. So here we are applying this for loop 2 times, okay, and we are applying the synchronized method for only one loop. Now let us execute this one. You can observe here. See, right? Thread 1 executes its execution, next thread 0, next thread 2. So all the previous thing is, all the 3 threads has been started, right? So first t1 dot start, t2 dot start, t3 dot start. So this is executed for all the 3 threads, right? Because this is not synchronized. So that's why our code is having, see, so starting the 3 threads are executing parallelly. There is no specific order 2 0 1 1 2 0 1 0 2 2 0 1. So there is no specific order. So all the 3 threads are combined and executed. So whenever it finishes its execution, next immediately the synchronized block is executing, right? So immediately we are writing the synchronized block, so this block will be executed. So whenever this block is executing, after executing one thread, the remaining 2 threads will be in a lock state, and after the next thread, the remaining thread will be in a lock state, right? Hope you understood this one. So that's why if you want to restrict only a few of lines in the synchronization, then we can go with synchronized block. I will just remove it, right? The third method is applying the synchronized static block. Synchronized static block. So this is very simple. So we know that for every static method we can directly call the methods by using the class name. We need not create an object for the static blocks, right? So we need not create a object for calling the static block. A static blocks can be called by using the class name itself. So everything we can remove it here. So synchronized static block, right? See, so in the void display I am writing synchronized static block. Synchronized static void display. So this is the static block, and in order to call this block, see, in order to call this method, this is a static method. In order to call this method, we need not create an object for this example. Directly by using the example class, we can call this method. So all these statements are not needed. See, all these statements are not needed. Right? Here, instead of creating an object, for example, directly call this with class name. So creation of this object is not required. Passing the object of example class to the thread is not required, because directly we can call it. Simple thing. Right? See, now also thread 1 initiated first. So thread 1 completes its execution, then only thread 2 will be started. Thread 2 or thread 0. So thread 2 starts its execution, so thread 0 will wait until it completes its execution. Now thread 0 started its execution. Right? So here it's a simple thing. We should not apply the static, synchronized keyword for the run method, because it is a overridden method. So that's why we are writing the instructions in a method of another class, and we are calling that method in run function. As we are keeping here synchronized static block, so we need not create an object for calling this method. We can call this method by using the class name directly. So example dot display. So in the previous two modes, in the previous two concepts, categories, we have to create a reference, and we have to pass that reference to the instance variable, so that the display method will be called. Right? So a little bit confusion will be there, but it's a very simple thing. So first, remember how to implement the multi-threading to apply this synchronization. So without using the synchronization directly, we can write the run method and everything here. Directly you can call it, call the methods. Right? See. So hope you understood this one. If you are having any doubts regarding this synchronization concept, feel free to post your doubts in the comment section, so that definitely I will try to clarify all your doubts. And if you really understood my sessions, share my sessions, like my sessions, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.